Hello, everyone, and welcome to today's presentation. I'm excited to share with you our course project on network troubleshooting. The title of this presentation is Network Troubleshooting, and it's part of the IT 6300 course. My name is ATIENZAJEDIDIAH. Today, I'll briefly walk you through what we've covered in this project, including the key concepts and approaches we use to diagnose and resolve network issues. So let's get started. Welcome to this slide on introduction. Network troubleshooting is essentially about identifying, diagnosing, and resolving issues that can arise within computer networks. It's a crucial process because, without a smoothly functioning network, all kinds of digital activities can be disrupted. The goal here is to ensure that connectivity remains intact, that the network is reliable, and that its overall performance is optimized. To do this effectively, we rely on systematic approaches, step-by-step methods that help us pinpoint problems efficiently. We also use a variety of diagnostic tools, which are essential in helping us analyze and resolve network issues quickly. Understanding these core concepts sets the foundation for everything else we'll explore in this presentation. It's all about maintaining and improving the health of our networks so we can keep everything running smoothly. Let's take a closer look at some of the common network issues that can cause disruptions. First, IP address misconfiguration is a frequent problem. If an IP address is set incorrectly, devices can't communicate properly on the network. Next, faulty cables or hardware, like damaged Ethernet cables or malfunctioning switches, can also lead to connectivity problems. Another key point is incorrect routing or missing routes. If the network routes aren't set up correctly, data might not reach its destination, causing delays or complete failures. DNS resolution failures are also common. When the domain name system can't translate a website's name into an IP address, users can't access the sites they need. Lastly, firewall or ACL restrictions can block legitimate traffic, either accidentally or intentionally, which can prevent access to resources or services. Understanding these issues helps us troubleshoot effectively and maintain a reliable network infrastructure, which is crucial for supporting our overall business operations. When troubleshooting network issues, having a structured approach is absolutely essential to save time and be effective. One of the most helpful frameworks we can use is the OSI model, which guides us through different layers of the network. Starting at the physical layer, I always check the cables, ports, and devices. Sometimes, the issue is as simple as a loose cable or a faulty port. Moving up to the data link layer, I verify switch configurations and VLAN settings to ensure that the network segments are properly isolated and communicating as they should. Next, at the network layer, I confirm that IP addressing is correct and that routing tables are properly configured. This helps us identify any misconfigurations that might be blocking traffic. Then, at the transport layer, I test TCP or UDP connectivity using various tools, ping, traceroute, or specialized network testing software, to pinpoint where data might be dropping. Finally, at the application layer, I make sure critical services like DNS and DHCP are functioning correctly, since they play a vital role in network communication. Ensuring these services are operational helps confirm that the network is not just physically connected, but also fully functional at the application level. By following these steps systematically, we can efficiently identify and resolve issues, keeping our networks running smoothly and reliably. Let's take a look at some essential tools for troubleshooting network issues. First up is ping. This command is incredibly useful because it tests the connectivity between your computer and another device on the network. If you get a reply, it means the devices can communicate. If not, there might be a connection problem. Next, we have tracert or traceroute. These commands help us identify the path that data takes to reach its destination. It's like following the route a package takes through the network, so you can pinpoint where delays or failures might be happening. Then there's ipconfig on Windows or ifconfig on Linux and macOS. These commands display your current network settings, such as IP address, subnet mask, and default gateway. They're vital for understanding your device's network configuration and troubleshooting issues related to IP conflicts or misconfigurations. Moving on, show IP route is a command used mainly on routers to display the current routing table. This helps us see how the network is structured and how packets are being directed within the network. Finally, we have debug commands. These are more advanced tools that provide detailed diagnostic information, often used by network administrators to pinpoint complex issues. They give granular insights into network processes and can be crucial for in-depth troubleshooting. Overall, these tools form a toolkit that allows us to diagnose and resolve network problems efficiently, ensuring our networks run smoothly and reliably. Now, let's take a look at some sample configurations you can work through using Packet Tracer. This tool is great because it allows us to simulate troubleshooting scenarios in a safe, virtual environment. For example, you might encounter misconfigured IP addresses on PCs and routers, which can cause connectivity issues. With Packet Tracer, you can practice identifying and correcting these mistakes. Another common task is testing connectivity using commands like ping and traceroute. These tools help us quickly pinpoint where a communication breakdown might be happening along the network path. You'll also learn how to debug routing issues by examining show commands, which provide valuable information about the network's routing tables and status. Finally, Packet Tracer enables us to identify VLAN misconfigurations. Proper VLAN setup is crucial for network segmentation and security. By practicing these scenarios, you strengthen your troubleshooting skills, which are essential for maintaining reliable networks. Overall, this slide highlights how Packet Tracer is a versatile platform for hands-on learning, reinforcing the concepts we've discussed and preparing you for real-world network management. Let's wrap up with the conclusion. Network troubleshooting really is a vital skill for IT professionals. When issues arise, having a systematic approach helps us stay organized and efficient. By using proven diagnostic tools, we can quickly pinpoint the root causes of problems. This not only saves time, but also helps us keep the network running smoothly. Remember, the goal is to resolve issues swiftly to minimize disruption. So, by applying these methods consistently, you'll be better equipped to maintain reliable network operations and support your organization's needs effectively. Let's take a moment to acknowledge the key references that underpin the information we've covered today. First, we have the Cisco Networking Academy's Introduction to Networks Companion Guide from 2021, which provides foundational knowledge and practical insights into network fundamentals. It's a great resource for understanding core concepts and hands-on skills. Next, Gallo and Hancock's book from 2015, titled Computer Communications and Networking, offers a comprehensive look at how data moves across different networks and the technologies involved. It's particularly useful for understanding the complexities of modern network communications. Finally, Oppenheimer's top-down network design from 2010 emphasizes a structured approach to designing networks, starting from the overall business requirements down to the technical details. This perspective is crucial because it reminds us that effective network design aligns with organizational goals and ensures scalability, security, and performance. These references highlight the importance of combining theoretical knowledge with practical design principles, which is central to mastering networking. They serve as valuable resources for anyone looking to deepen their understanding or build on what we've discussed today.